What is going on, you guys, and welcome back to the channel. In this video we're going to be looking at a Python library called Pydantic. Now Pydantic is a library that is gaining popularity as it provides us with easy ways to validate data and enforce Python type-ins. Another great thing about it is that it provides user-friendly errors and gives us easy ways to custom validate certain fields. Now the implementation of Pydantic is very similar to that of data classes, as you'll see in this video. And that, when I say data classes, I mean the data classes that come with the Python standard library. However, we shouldn't think that Pydantic is there to replace data classes, as both have different use cases. For example, with Pydantic, it's a big part of the FastAPI ecosystem and has many uses when it comes to web applications in Python, such as when it comes to building APIs, it can be very useful for serialization. Now in this tutorial we'll just go over what is needed to get up and running with Pydantic, as well as going through some cool features that come with it. Now just here I have the documentation website opened up, and definitely feel free to check this out, as it comes with a lot of, as you really get to see how extensive this library is. But anyway, let's get into the code. Now I've just created a virtual environment for this Python project, and so feel free to go ahead and do that if you want to code along. And the first thing we need to do is install Pydantic. So for this I'm using pip. It's going to do pip install and then Pydantic, like so. Hit enter, and there we go, we have Pydantic. Alright, so what we're going to do is we're going to use this thing called base model that comes with Pydantic to create our classes. So we'll say from Pydantic import base model, and let's create a class that represents a student. So this will be student, and it will inherit from base model. Now here we'll define all the fields of our student. So what makes up a student? First we'll have a first name, and then we're going to have string. So like I said earlier, Pydantic is there to help us enforce Python type-ins. So in this case we will say that the first name is a string and it must be a string. Then we'll say last name and then string. Then we'll have an age, we'll say that's an integer, and we can add a date joined, so when the student joined, and this is going to be a date. So what we can do is say import date time, and then here we'll just say date time dot date, and then finally let's add a level. So what level is the student at? Are they beginner, intermediate, or advanced? And this will leave it as a string. Alright, so that's pretty much a Pydantic model, and what we can do now is go ahead and mess around with it. So we'll say student equals student, and then we'll say the first name is Harry Potter. Oh, sorry, the first name is Harry. The last name is Potter, and then the age we'll say is 18. Let me just bring that bracket back in, and we have a date joined, which will set that to datetime dot date and say 2020 1st of January. And then finally we'll have a level, and we'll just set this level to beginner. Alright, so what we can do now is go ahead and print out the student. So we'll say print student, say Python, and then main.py. And we get this nice clean output. Rather than seeing the address in memory, the Pydantic library handles all the kind of readable side to it. So we have first name is Harry, last name is Potter, age, and etc. So we're looking at very primitive types when it comes to our Pydantic model. Instead, let's say we want to have an enum for our level. So instead of having like a manual string that we have to enter, let's have something a bit more concrete. So we'll say class level. We need to import enum. So from enum import enum, and this will just inherit from that. And then we'll say the first one is beginner, so that's 1. Then we have intermediate, which is 2, and then we have advanced, which is 3. Alright, so now we have our level enum, and we can now use that as one of our types. And so if you've played around with the data classes library that comes with the Python standard library, This all may seem quite familiar to you, as yeah, Pydantic in terms of implementation isn't that far off from it. So here we'll say level like so. However, right now with our current student, we've set the level as the string beginner. So if I were to run this, and remember, like I said earlier, Pydantic is there to enforce these type hints. So if I run this now, we get back this error, and it's saying to us that this level is the wrong type. It should be an enum, and it gives us the enum values that it should be. So level beginner, intermediate, and advanced. So what we can do instead is say level and then advanced like this. Now if I run this, we get back level and everything works out. There's no errors, and we see that the level is now this enum value. Alright, so there's also some nice custom validation that comes in, and this is where you really start to see many of the differences between data classes and the Pydantic library, in that Pydantic is more there for validation and serialization, whereas data classes have a more general sort of use case. So here, in order to validate something, let's say we want to validate the age. We want to say that a student has to be above the age of, has to be the 10 or above. So what we can do is here on line 1 with our Pydantic import, we can import this thing called validator like so. And then down in our student class, we can say validator like as a decorator, and then we have to specify what field we want to validate. In this case, we're going to validate age. Then we can name it whatever you want. I'm just going to call it validate age. And this is not a self, but rather a class method. And we'll say age like so. Usually you see V. I think in the docs it says V, but I'm just going to say age to make it clear what we're playing with. So let's just have a look at what this prints out first. So if I just say age like this, let's just return age at the end of it. So if I run this now, we can see here that the output is 18, so it gets the age. All right, so what we can now say is if age is less than 10, we can raise a value error. We just have a value error for now. We'll say age must be 10 or above. And then otherwise, if there's no error, then just return the age. So send that age back to here, everything's good. So if I were to run this again, we get everything's fine because the age is 18. If I set the age to 8 and run this, we get an error which is age must be 10 or above, and it's telling us that it's a value error. So pretty nice there in terms of how you can validate, add some custom validation. You can also validate multiple fields at the same time. So for example, let's say we want to, if you're going to validate level, let's say a student who's advanced cannot be less than the age of 14. So what we can do is say validator, and we'll say level, and then we can say validate level from age. Again, this is a class method, and then we can say value, or we can better still say level, and then values. Now this values is basically what has been inputted, all the other fields. So we can just print this out for now. Let's just print out values, and let's just return level for now. So now if I run this, we just need to clean this one up. Let's set this age back to 18. So if I run this, we get back, so this line here where I'm highlighting, that's the value. So it comes out as a dictionary, and we can see all this sorts of input that have been put in there apart from level, because in this one we've said we're going to validate level, so don't set level just yet. Now what we can do is say if value, or better still, if value is level dot advanced and age is less than 14, then raise value error. To be advanced, the student must be above 14 or 13 in this case. Alright, and we get an error here because what we need to do is access the age inside values, so values and then age, as you saw in the output just down below. And then this here is not value but rather level. Now if we run this, and yeah, we still have that print statement, but everything works out because yeah, in our case the age is 18 and they're advanced. So if we were to set something like 12 here, and now if we run this, we get this error, which is to be advanced, the student must be above 13. So it's very easy to add this in. Now, another thing is that you can make certain fields in your class or in your base model optional, so they don't need to be required. So to do that, we can say from typing import optional, like so. And then let's say that the level itself is an optional one. So we'll say optional, like so. Now what we need to do is change this validation because now the level is not required. So we have to say if level is not none, then we need to just tab all of this a bit. But now I can leave out this level thing in our student. So if I run this, we just get back the other fields, and then we see here that level equals none. However, if I were to remove the required fields, so for example, all the other fields are required. If I remove the, let's say, date time one, just comment that out for now. If I run this, we get back field required. That's because by default, all the fields are required unless you specify that it is optional. All right. Now you can also set a default value. So we can say here that level.beginner. Now if I run this, given that the advanced field has gone from our student, we get back level is beginner. So pretty easy to get all that stuff up and running. Let's just set that back to how it was. All right, now remember that we have this age validation. There's some cool validation that comes with Pydantic. So we can also validate the age in a different way. And to do that, let's go ahead and import this thing called conint. And this just means, I think, constrain integer, something like that. Now here we can say, instead of int, we can say conint. And we can add something like, let's say that we want the student to be greater than or equal to 10 and less than or equal to 20. So in order to do greater than or equal to, you type in GE and then 10, and then less than or equal to LE, and then say 20. So now what we can do is remove this. And if we were to go now and set our age to 9 and run this, we get, ensure that this value is greater than or equal to 10 because our age is 9. If we were to do something like 21 and run this, we get, ensure that this value is less than or equal to 20. So it's pretty smart in terms of how easy it is to add validation to our models, and that's definitely one of the perks when it comes to using Pydantic. You can also have this thing called constrained string or constr, and that will do this a similar thing but with strings. So for example, let's say we want our string to have a max length of, say, 2 characters. So first name, max length of 2 characters. And given that our first name is Harry, if I run this now, we get first our first name error and our age. So it validates both of them. It doesn't just fail at the first one. So this one's saying ensure that this value has at most 2 characters. And then we also get our age because the age is set above the age of 20. Let's just go back to the age being 20. And yeah, so you can have this constrained string. I'm going to set this to 255. And then here, set this to max length of 255. All right, so the validation side of Pydantic is really useful. It's very powerful, and yeah, that pretty much is it with our student class. Let's go ahead and create another class, but this time the class is going to represent a course. So we'll say class and then course, again inheriting from base model. This time the course will have a title, and we'll say that this is a constrained string of max length of, let's say, 30. And then we have the teacher, which will represent as a string. And then we have students. Now our students is going to be a list, but it's going to be a list of this student. Now what we can do is say that, okay, our course is going to have at most 10 students. So we can use this thing just like we have with conint and constr. This thing called conlist as well. So yeah, you're probably thinking like, wow, there's so much that comes with Pydantic. It really is quite a large library. But for our case, let's say our students are optional as well. So a course doesn't have to have students. Let's say it's the start of a semester, then of course no students have, or just the beginning of the semester, no students have signed up. And then here we can say conlist, like so. Then we can specify the type that's going to be put in there. So we'll say item underscore type, and we're going to equal that to student. Then we'll say that the max items is 10. So a fairly small course, or courses are fairly small in terms of student capacity. And yeah, so now what we can do is create a course, and we'll say this course has a title which is history, and the teacher is, say, Albus Dumbledore, and the students, actually we can leave the students out because we have that as optional, and that will be set to none because we've set it to that. So let's print out the course like so, run it, and we can see here that we have our course and the students are none. But let's say we want to set the default to an empty list. All we have to do is say equal at the end of students and then create an empty list like so. Now if we run it, we get back students equals empty list. All right, so let's go ahead and add a student to it. So we can go ahead and let's just remove these print statements. We'll say course and then students dot append and then student. Then let's just go ahead and print out our course. And you can see here that we have our course, and then you see our list of students, which includes one student so far, which is Harry Potter. The last thing I want to show you is how easy it is to serialize or get different representations of your base models or your Pydantic models. So for example, we can print out a dictionary format of our student. So we have our last student, and let's say dict like this. Now if I run this, so Python main.py, the last line we see, actually let me comment out the last print statement, but the last statement or the last print is a dictionary version of our student, and you can see here how some of the types have been respected, how many of the types have been respected, like the age is an integer and the dictionary repeats that. The level, we can actually go back and specify that, so we can see what that'll look like. Say level equals level dot advanced. If I run this, we can see that the level is set to this enum value here. All right, so what did I do here? Never mind. The next one is that we can also have a JSON representation of Pydantic. Now this is particularly useful if you're, let's say you're writing to a MongoDB database, or you have an API that needs a JSON response. This comes with Pydantic. So in order to do that, all you have to do is say print and then student.json and then hit enter. And you can see here that we have the JSON representation of that, with the enum now being represented by the value, because in JSON you don't have default, or you don't have enum values. Now again, we can see what our course will look like if we did a JSON one, as that holds in our student. So you can already imagine what that'll look like. So if we run this, you can see that we have our course with the title, teacher, and then the list of students where we have Harry Potter and the date that they joined, which is automatically turned into a string format, and then also the enum as well. So that pretty much brings us to the end of our Pydantic tutorial. I definitely recommend reading the documentation that's there, and I'll add the URL to the description, which it just gives and it shows so much more that comes with Pydantic and the sort of ways you can make use of it when it comes to building things like web APIs or other use cases that you may find from it. But anyway, stay healthy, stay safe, and I hope to see you in the next video.